From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show. Welcome back. Kaushik. 2020's kicking along, moving along just fine. How's it going for you?
Pretty good. 2020 is, I finally got my 2020 blog post out sometime around Feb. Usually people tend to write these pretty early on, but I don't know, after a certain point when I couldn't hit Jan 1st, I realized, you know what, it doesn't matter. And this year I really took it. So I kind of released it on Feb, the first week of Feb, but that was good. I feel, you got to take life as it comes.
What does your blog post talk about? Just a year in review or what is it?
So that was another interesting thing. Typically when folks write these posts, they either write it as a year in review kind of thing, right?
Mm-hmm.
For me, it's more like a transition. So I write both how the year went and what my, in quotes, New Year resolutions are going to be.
Mm-hmm.
Just like as I try to keep like specific goals that I'd like to hit for the new year and what happened in the past, I try to review based on, what I've written. Because it is I've noticed that it has worked out pretty well for me in the past when I explicitly state to the world what I'm trying to do.
Yeah.
Because then I don't have an excuse, right? It's like if you declare it outside, then it's almost like you're forcing yourself to hold to those commitments.
Publicly accountable.
There we go. So this year I basically wrote a very similar post, and I made it a little different this year where I kind of explicitly, I like to usually keep it into 3 sections. This year I realized that I like to keep it in 3 sections. One is the top is the recap for how the year went. 2020 is what I plan to do. The next section is my goals for the next year. So what I plan to do in 2020.
Mm-hmm.
And just in the end, I throw in my random learnings from the year, because what I do is over the year, I try to pick quotes that I've run across that I thought were interesting if I ran into any music or movies. I didn't do that good a job of documenting these. I did, but then because, as you know, I changed my note-taking tool, I kind of lost some of those stuff, but I usually that's how I try to section it. I think at one point when we talked before, you said you were not too big a fan of New Year resolutions, right? Or no, are you ambivalent towards the whole concept?
Yeah, I'm not really huge on New Year's resolutions because a lot of people just, in my opinion, they use it as an excuse to say, well, I'll just do that at the beginning of the year. Let's say it's December 16th, right? I'll just start it in 2 weeks. Why not start now? Okay, for example, let's say you totally screwed the pooch on, as it figuratively of, with your diet at the beginning of January. And you're just wow, I totally screwed that up. Okay, start over. Go now. Just start now. We all make mistakes. Life is never a continual schedule of all right, you can only do this here and here and here. We have just arbitrarily attached time frames to the number of times that we go around the sun. And even then, if you look at leap years, it's not even exact. We have to make adjustments along the way. So even time, our concept of time is adjusted. So it's just one of those things. I just feel if you have something you want to do, then just do it.
Yeah, I like that. I think you're way more disciplined in your thinking. And it is right. I think there is an aspect of it where if you don't get it, if you tend to fail early on, you tend to almost abandon ship altogether, right?
Yeah, that's very common. The same thing happens when people stop, hey, I'm not going to drink as much, or I'm going to stop eating candy, or I'm not going to eat ice cream, and then they slip up, or I'm going to be on a diet this week, and then on Monday they go out and they mess up and they have pizza Monday night because of a work outing. And they're well, I already messed up Monday. I might as well just go ahead and keep eating Tuesday or something like that. That's just, you do have to be more disciplined. Say, hey, you know what? I, made a mistake last night and I ate something I shouldn't have or whatever. And I'm just going to start over tomorrow. Or the same thing, hey, I didn't go to the gym today. That's fine. I'll just go to the gym tonight or I'll go tomorrow. And you just kind of have to readjust with it. I think New Year's resolutions can be good if you can stick to them. I just feel that too many people don't stick to them. You know what I mean?
No, that's entirely fair. It was interesting. This time I made it a little different because it was like the reverse of what you said. I almost gave myself the opportunity to not fail because I split it into like specific goals. Because typically in the past, I did the exact same thing that you mentioned, right? I was like, oh, I got to go to the gym more. Oh, I got to do X more. I got to, eat more healthy or that kind of stuff or sleep more. Which, in all fairness, like served as a reminder as I went through the year to like improve those things. But this time I almost made it more specific, right? Like, for example, I wanted to be writing more blog posts. So then I said, I got to give myself a specific goal. So write 24 blog posts. So, if I didn't write my first blog post like the first month, that's fine. Like, I can make up. It just means I'll have to make up. You are right in that, if I let it go for too long, if I'm in month 6 of the year and I have to catch up, then that makes it worse. And then, by the time month 10, if I've done nothing, then at that point, it's a complete fail, right?
Yeah.
But that's where the publicly accountable thing helps because then I'm like, oh, okay, I basically got jack done last year.
Exactly. I think one of the things that a lot of people suffer from, and I know I've suffered with this many times, is setting lofty goals that are almost too hard to accomplish because the required change in your life is so significant that it's just a complete shock and just disrupts your entire day-to-day life. And so, you might say, hey, I want to get healthy and I'm going to work out, I want to work out 6 days a week and I'm going to eat healthy every single day. And I'm also going to read 1 book a week. Like if you start looking at all these things, like that's a completely different life. So like, in my opinion, one of the best ways to go about like long-term change is like small, just like we develop software, it's iteratively. It's like, okay, what can I do that's going to help get me on the right path? And like kind of course correct me, like steering a big ship in the new direction. Like instead of going to the gym 7 days a week, I'm going to aim for 2 because I don't go at all. I'm going to aim for 2. And then in 6 months or 3 months, I'm going to reevaluate and try to go to 3. And instead of eating healthy 3 meals a day, like I'm going to try to eat one salad a day or a salad every other day and slowly, iteratively move that way. And I think one of the best concepts I learned this from was James Altucher and his concept of just being 1% better than yesterday. And if you compound that over time, like 1% is not that much, but over the course of a year, like that's a lot. Like you're completely different life. So if you can keep that in mind, that's for me, that's worked great. And it's something I just try to do because it works for me.
I like the idea.
Totally off topic, but you had mentioned something to me over chat regarding this time problem that, to tell you the truth, I was not aware of. Can you fill me in on what it is and the listeners?
For sure. So typically in programming, there have been times where certain years have caused some problems, right? Yeah. With the way we write programs and the way things function. So there is the most common one, which we'll like maybe go through in a bit, is the year 2K problem, right? Y2K.
Yeah.
So year 2000 for different reasons caused like a lot of havoc, or at least, presumably caused a lot of havoc in the minds of a lot of programmers. And we'll explain what it is and why. There's also, like, did you know there's also one coming up where many suspect that could be a problem? It's called the year 2038 or, 2038, depending on how you pronounce that. There's a year 2038 problem.
I had no idea till you actually sent me this. I was like, what is this thing? And then I looked it up and I was like, oh, that's kind of a big deal.
And it's interesting because I think both these problems have to do essentially with the root cause is the same, where basically the memory storage chosen in order to accommodate these 2 years is basically in one way or the other failing, right?
Yeah.
So maybe we should go through like quickly what it is. So year 2000 was like a kind of, sort of straightforward. The funny thing with Y2K, did you remember the Y2K fiasco when it happened, where everyone's like, oh my god, Y2K, the world might end, this might happen.
I was just getting into web development at the time, and I had some freelance clients, but during the day I was a stockbroker, so I worked at Charles Schwab, and
Oh, wow.
I remember this very vividly. I had to work that day, and we
Is
were
there
not.
anything you haven't done? You've been like a race car driver, you've been a stockbroker, you're a programmer, you've been like the member of a band, and I'm not even like joking. You have basically been all of these things, right?
I'm like 74 years old.
There's an amazing show called Dracula on Netflix that I recommend. Yeah,
yeah?
you get a
That'd be
sense
cool.
of, it's basically, yeah. You should definitely watch it. It's probably your kid or something.
I'll have to check it out. But I remember showing up to work that day. I remember going to bed that night. Everyone's wondering, like, is the world going to end? Like, it was. Some people were just freaked out about it. So yeah, I remember that day very vividly. Do you?
Yeah, I mean, it was also like very early in the days of my programming career. And the funny thing to me is I was like, oh, it's such a simple problem. I understand the problem. Why is this such a, why was this such a big deal? Why didn't people just like, change it? It seems so simple. Maybe we should go through what
what is, let's talk about what is Y2K.
Yeah. So the crux of the issue was typically the way people would represent dates, say, January 1st to 1955, right? The way people would represent this date was 010195, right? The example I gave was 54. So 010154, right?
Yep.
Essentially, if you had 1954, you would chop off the leading two numbers. So you would remove 19. And this was great because, like, when they probably started this in the 1900s, they were like, yeah, great. Like, we don't have any problems. We can go all the way till 2000 and we'll deal with it when we get there. Mm-hmm. Obviously, at the time, people didn't expect this whole computer science thing to, like, take off and have programs, or like most people who wrote programs at in that year didn't really expect this to their software programs to last that long or like reach all the way to the year 2000. I'm trying to see if I can pull it. I'll try to pull it out as we go. There was this quote by Alan Greenspan, and he mentioned, there we go. There it is. I'm one of the culprits who created this problem. I used to write those programs back in the 1960s and 1970s. And was proud of the fact that I was able to squeeze a few elements of space out of my program by not having to put a 19 before the year.
Yeah.
Back then, it was very important. We used to spend a lot of time running through various mathematical exercises before we started to write our program so that they could be very clearly delimited with respect to space and the use of capacity. It never entered our minds that these programs would have lasted more than a few years. As a consequence, they are very poorly documented. If I were to go back and look at some of the programs I wrote 30 years ago, I would have one terribly difficult time working my way through step by step.
Yeah.
Man, I feel like that about the programs I wrote like 2 years back.
Yeah, but it goes to show like how much back then, I mean, this is like punch card era, when saving that much space, like just two characters or what was represented down at the low level, it was very important. And so that was the decision they made. And like he said, and we've said, is that they didn't know that some of these programs they're going to be writing are like going to be running around still at 2000. It's like, you don't even think about it. And it's possible now that we're writing software that could be around for 100 or hundreds of years that we don't even contemplate, like going, oh, let's hit the API 100 times. And like, oh, that's a real bad thing for whatever reason,
Right. And I think you hit it right at the crux, right? Because my question at the time of Y2K is, this is such a stupid problem. Why don't you just put 2 more digits and be done with it? And, let's all move on, in our lives. But obviously, I did not have the context that in that, I remember reading this, like probably in the Wikipedia article. Storage and memory was really expensive back in the day. Like literally, I think the ratio was you would pay $1 per bit. That is BIT bit, right? And if you think about that, like that's a lot of money, right? At least at the time, with how expensive equipment was, it's crazy, So there was a need to like really compact this stuff. It wasn't done out of like, this esoteric or, proud programmer ego or something where I was like, oh, I can make this thing in the most like few number of lines of code and like few storage and space. There was a genuine need at the time to be able to shrink and compress all of this into as small a data structure as possible. So that was Y2K. So at the time, what happened is I remember as we got closer to 2000, people started to freak out because they were like, wait, what happens after December 31st, 1999, right? Because it flips. And if you only used 2 digits to represent, you would be going back to 1900, right?
Yep, exactly. The computers had no idea if the programs were like, I don't know if this is a 1900 or if we're in 2000. And so that could create what were known as event horizon problems inside of programs, which means that, like, who knows what would happen? Like, it could crash, all different kinds of things could happen.
Absolutely. Because that was the issue, right? I think the whole problem was the unpredictability of what would happen, because that's how you would calculate date time, right? And that's pretty important, you would think, in most programs. And if that fundamental concept is broken, where you're not reliably able to tell dates, you can't do date time arithmetic, that could be pretty problematic.
Yeah. So when they were starting to realize this in the mid 90s, and the British Standards Institute, which is known as the BSI, came up with 4 rules for conforming to year 2000. I'll just read them here. The number 1 is no valid date will cause any interruption in operations. Kind of makes sense. Number 2, date-based functionality must behave consistently for dates prior to, during, and after year 2000. Makes sense. Number 3, in all interfaces and in all storage, the century must be unambiguous, either specified or calculable by an algorithm, which kind of gets us to the 1970, 2038 thing. And a year 2000 must be recognized as a leap year, because we start getting into leap year problems, and we don't even get into time zone things.
That's right. I remember that was the other big. So I think in year 2000 was the time I realized how leap year calculation was actually done.
Yeah.
That was the funny thing, right? Because typically at least I don't know how it was for you, but for me growing up, the easy way to tell if the year is a leap year or not is if it's divisible by 4, right? And then there was oh no, it's not actually 4, it's 100 or something. But I think eventually the right math was every year that's divisible by the number 400 is truly a leap year.
Yes.
Right? If it's not divisible by 400, not 4 or not 100, but 400, only then would it be a leap year, right? And this obviously becomes important again because, and you actually, when we started this out, you mentioned something, right? It's time is completely arbitrary, and we've made this up, and we make these adjustments so that, it self-corrects itself.
Yeah.
But eventually the problem always boiled down to, can you make proper assumptions, right? If Feb should have 28 days or 29 or how many ever days it needs to have, it's important to know if a year is a leap year or not, because all your calculation, your date time arithmetic again would go wrong if you didn't get it precisely down.
Yeah.
Right?
And so for those of you that are what, this kind of brings up a big question of well, why do we have leap years? And then we start getting into all kinds of planet science and stuff like that. But, as programmers, we kind of have to think about these things when we're dealing with a lot of time stuff. But in the show notes, I'm not going to get into it here. I'll put a link to the leap year explained by Neil deGrasse. How do you say his name? Neil deGrasse Tyson? I forget.
Yeah, I don't think I can do a better job than you there. Yeah.
So he's, was he a physicist or something? Astrophysicist or whatever?
Popular, famous, astrophysicist.
But he has a 3-minute YouTube video where he explains why leap years are here, what they are, when they're calculated. And it wasn't until I saw that video a few years back where I was just oh, this all makes sense. It's basically because we can't equally divisible the time around the sun. And he explains it really succinctly. So I'll add that to show notes. Won't get into it till now.
Oh, that's awesome. I haven't seen his video on that. I'm excited to see this as well.
So what is this 2038 problem? Now that we know the Y2K problem is.
Yeah. And I mean, just before we move to 2038, right? The other question I had is did it actually cause a problem? Because now we are in obviously 2020, right? 20 years after the Y2K problem, did it cause problems? And Wikipedia has the documented errors, so we won't go through, but it actually did cause some problems because the funny ones I picked out is taxi meters in Singapore apparently stopped working, while in Sweden incorrect taxi fares were given. And it also got pretty scary because in Japan apparently an alarm sounded at a nuclear power plant at 2 minutes after midnight. So, some of the stuff is like not to be taken like, too casually. And I remember there was like some other really weird ones where like, there was some that were pretty serious because hospitals made the wrong calculation, like in certain like abortions or something, because like they got the date wrong. Reading some of that stuff was like pretty scary. But anyway, there were actual problems. Like this isn't just a hypothetical thing that we just, in California we have this saying, because it doesn't rain that often. Like even if it's a mild sort of like rain, like we get a few centimeters of rainfall, everyone like freaks out here because they're like, oh my god, it's like the worst storm that's happened in like 1,000 years. That was not the case. Like there were actually genuine problems, but for the most part, I think a lot of people did react well to Y2K.
Yeah, and there's actually, just to cap this off here, we're still dealing with errors from this. There was an error that occurred January 1st, 2020, related to Y2K. And that was some of the parking meters in New York City basically stopped. They started refusing credit card payments because some of the software that was used on them was using a date windowing, basically using 2 digits to calculate dates, and it was using the wrong year.
What? That's crazy.
Yeah,
so
meters.
I guess like the problem still like plagues us in some way.
Yeah. So,
all right. But sorry, you asked about the year 2038 problem. The reason I brought this up is because this is interesting. It's in the same vein, but it's actually a completely different problem.
Mm-hmm.
So as we know, typically when we're working with Unix systems, right, and like date in general with most of these computer software, typically we use a signed 32-bit integer to represent time, right? And the way time works is this is like a very interesting topic in itself, but we basically represent time as the number of seconds elapsed since, I think it's 12 midnight UTC of Jan 1st, 1970, right? And there's like a lot to like break out. Yeah, there's like the epoch, exactly, right? So since time elapsed since the epoch, right? And typically if you've dealt with anything to do with date, time, and time zones, even in Android, you would definitely have dealt with this problem, right? Because if you do to time, or you dot to time, that is, and you convert a date object to like milliseconds, or you want to do the math, typically you would drop into using signed 32-bit integers, right? Because that's what is used by default. And the Unix system uses signed 32-bit integers as well. The problem is the max that the maximum number that can be held by a signed 32-bit integer is for computer science nerds, it's 2 power 31 minus 1, because it's signed, so you don't get all those 32 bits, like one of those bits is taken away. And obviously the max number is 2 power 31 minus 1. And that happens to be, I don't think I can get this right, but it's 2,147, or like, 2,147,483,647 seconds, right? And interestingly,
that's the number of seconds that's elapsed after January 1st, 1970.
Yes. If you take that many seconds, which is the max that's represented by a signed 32-bit integer, it basically crosses the threshold after 1970. So in year 2038, we're basically going to have like an overflow. So that I didn't actually even think about it, but I think I ran across it somewhere while reading, and I was like, oh wait, why would that be a problem? And then I was like, oh, this is interesting. So obviously there were like multiple ways to solve this. Like, you can, I think a lot of machines moved to like a 64-bit sort of architecture. So I guess that like helps that. Obviously don't use a signed 32-bit integer. Mostly I think the correction is if you switch to 64-bit, at that point, because again, my thinking was like, is this always going to be a problem? Like, why is this such a big problem, right? Because why can't we just pick a big enough data structure that would just alleviate this problem and we don't even have to worry about it ever? But obviously, again, it's the same thing. There is a constraint in time and space. It's the same thing. I think maybe I tweeted it out because you know how at one point it was Google or someone ran into this problem with IDs with, monotonically increasing IDs. You at some point you're going to reach like the maximum threshold, right? And given if you have something that just has a huge number of counts, I think like Google, if you just take the number of search results or like, the number of search hits, that number is going to increase pretty damn fast, right?
Mm-hmm.
So I think they also ran into something similar where they had to change the way that they use their IDs. It's kind of it's in the same vein where you're like, hey, can we not use something that just isn't limited by space? I'm trying to find it here on the page, but basically the idea is if you move to 64-bit, essentially we're not going to hit this for a very, very long time. So it isn't like just double of 32; it's actually like way longer.
Yeah,
and basically it'll take. We're not even sure like the galaxy will be alive at that point. So yeah. Oh yeah, here you go. Using a signed 64-bit value introduces a new wraparound date that is over 20 times greater than the estimated age of the universe. So it's approximately 292 billion years from now.
we should be all right by then.
Yeah. So yeah,
We got plenty of time to figure it out then.
Yeah, this isn't from like a 1900 to 2000 problem. This is like way past that. So I think we should be good. But the funny thing with epochs, and this is something that I think the last time around when I was reading up on this, I realized. Do you know why they picked 1970?
No, why did they do that?
I actually don't know myself. It was just, I think it's like totally arbitrary. The idea is they just needed to pick, well, I don't think it was entirely arbitrary, but they needed to pick, because my thinking was, why don't you just start from 1900, right? Like make it nice and round, or like why don't you start from, from the start of time, 000. Obviously that I think would have helped, but anyway, what is so significant about 1970? I don't think there was anything necessarily auspicious or significant about 1970, but they wanted to pick probably a date that was further along. So then again, you could increase how far ahead you could go to, right? Mm-hmm. So I think maybe that was the idea. And also like I would guess that's the idea. And the other funny thing is that epoch, there isn't just one epoch. Like, we think traditionally because Unix is so popular, and like that's like mostly the operating system that's used in most servers and other utilities, we tend to think that that is the epoch. There are actually multiple epochs.
There are, yeah.
Yeah, so like, and depending on, I can't remember some of the others, but yeah, they chose again arbitrary dates, right? And those tend to be epochs for those systems. So there wasn't anything really significant. The only thing I could the only rationale I could come up with is they wanted something that was significantly ahead, and then that would just like give them some leeway to use that.
So what do we like as developers? What can we do to make sure that our applications don't suffer from this? If maybe we're Android developers, do we use something like Jota time, or does this handle for us, or do you think we have to calculate this ourselves, or it seems like something that we should be handling instead of libraries that we use? Or do you have any thoughts on that or any experience?
Nothing much. I mean, I didn't necessarily. I would think the idea is it would depend on how you store your dates. Like if you are using a sign, if you look at what we use, and if it's a signed 32-bit integer, like you're in trouble, right?
Yeah.
And again, there are like different strategies. You can like migrate from using a signed 32-bit to a signed 64-bit. That's what most people recommend. Mm-hmm. Typically, I think those are at least as programmers, like the programs we write, those are easy enough to implement. But I know, because I don't remember where I read this, or maybe I heard from like one of my colleagues at Instacart, when you move ginormous databases and systems, it isn't that easy, right? Like even like updating your architecture. I think Mac OS just recently now made 64-bit mandatory. So I think with Catalina, it's mandatory. Like all your 32-bit programs stop working, right? Yeah, exactly. So that's, as you upgrade your architecture, I suppose that would help. And I mean, that might take care of some of the problems. But hey man, we got like another 18 years to think about the solution. So
I think there are some applications that from research I've done before we hopped on the call that some have already kind of run into the situation because perhaps they're dealing with years in the future to for whatever reason, whatever the program is. So there are some folks who have run into this. So it's something you probably do want to think about if you're using something like Joe to Time, if you're in Java or Android, or if you're using Moment.js, if you're in JavaScript or Ruby or whatever. Check your date library, see if it's handling 2038, see how you're storing your dates. It's just something I think that's important to think about as developers going forward, because it's just going to set you up for the future so you're not running into like another Y2K like issue. And then we don't have like Office Space 2038. So that would be a good movie.
Oh yeah, that definitely would be very interesting.
Staplers.
Yeah. So yeah, I just wanted to bring that up. Anything else you wanted to throw in there as we talk about these interesting problems?
Nope, just think it's like you said, it's an interesting thing. I wasn't even aware of it. I'm glad you brought it up, and we wanted to let the listeners know about it. So if you folks are out there building applications based upon date and time and all that fun stuff, then you know what you have to look out for.
Alrighty, folks. Thank you for listening. Make sure you get your 2038 sorted out, and we will catch you not in 2038, but in the next episode. That's it for the show, folks. Fragmented is hosted by Don Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.